Here's number 31. Need to lower my marker a little bit. Can't write as thick when we zoom in. Alright, what is the area of RST? So we need the entire triangle, not just one half of it like I did yesterday. Okay, so here's a right triangle here on this right side. And then we have a 9 over here and a 15 there. If this is a right angle, then what kind of angle is right beside it? A right angle, that's right. So if that's a right angle, what can I do to solve for this side right here that I'm going to call X? What can I do to solve for that side? Pythagorean theorem, yes. That's right. So you'd have to do 9 squared plus x squared equals 15 squared. So x squared would have to be equal to 225 minus 81. And 225 minus 81 is going to be what? 140. Is that 141 or is that 144?
144.
144. Okay, so x would have to be 12. So if I have a side here that's 12, then yeah, we can use the Pythagorean theorem here and here to solve for what I'm going to call y. So y squared would be equal to 169 minus 144, which is 25. So y is 25. No, y is not 25. Oh my God! I said that, and I looked, and I thought, what is wrong with that? It's 5. Good grief. Yeah, so that's 5. So now we need the area of the entire triangle. Now the area of a triangle is what formula?
Base times, or half times base times height.
Yes, 1/2 base times height. What is the base of this triangle? What? It's 14, right. So we have 1/2 times 14. What's the height? 12. Alright, so half of 14 is 7 times 12 is going to be 84. Well, we just covered this in Algebra 1 just this week. As luck would have it, this is Algebra 1's lesson this week. If you want to find the x-intercept of an equation of a line, then all you have to do is put in a 0 for the y. So 0 equals 2x minus 8. Move the 2x to the left, change the sign, divide by -2. X is 4, but you have to remember that y is 0. So it would be C. If you want to find the determinant, you got to remember that the formula is AD minus BC. So if you make this A, B, C, and D, then you would have 3 times 2 minus, what is that, 6 times -1. So 6 plus 6 would be 12, and they have it in the brackets like that. So answer would be K. Oh, that was a bonehead move. This was irrelevant. The absolute value is 12. They've thrown it. Even I got fooled on this. I had to go back and restart the recording. But no, it's absolute value of 12. And technically this is right, but it's not simplified. This is 12. That's the absolute value of 12. So the answer is G. Music is right. Yeah, I looked over at the key and it said G, but I circled K, and I'd made the same mistake that a lot of people would. And that is, you see the absolute value of 12 as one of the choices, and that's not it. That's the same thing as saying you have 4 over 2, and answer D is 4 over 2, but what's really the answer? 2. So if A was 2, then A would be the answer. To solve this problem, this 1 over 49 must be expressed as a power of 7. Now, 7 to what power is 49? Second, but since it's a fraction of 1 over 49, what sign is on the exponent?
Negative.
-2, right. So then in parentheses you have this outside of it. Over here, the square root of 7 is really 7 to what power?
Negative.
Not negative.
Half.
Yeah, it's a half, right. So now we have to do this. You have to multiply the exponents together here in this case. When you have an exponent on parentheses and then on the inside you have to multiply them together. So that would really be 7 to the -2 times the quantity n plus 3 power. So since you have this to this power and this to this power, therefore this must be equivalent to this. Those two powers must be the same. Because if you have the same base here, their exponents would have to be the exact same. So distribute, come up with this, and then -2n equals a half plus 6. So what is that going to turn out to be as we find some more room here? What's half plus 6? 6.5. So n is 6.5 divided by a -2. So I got to move over this way some more. 6.5 is the same thing as 13 over 2. And if I'm going to divide by a -2, that's the same thing as multiplying by a -1 over 2, which is a -13 over 4. So the answer is J. Here's a... In 37, you have to draw this stuff. So here's a wall right here. And of course you have the ground. And the ladder stands against the vertical wall at an angle of n degrees. So we have no clue how steep this ladder is going to be, so we'll just draw it like this. And it's n degrees with the ground. So we'll put the n degrees there at that angle. If sine n is 4 over 5, do you remember what sine is? Opposite, adjacent, hypotenuse. What is it?
Opposite hypotenuse.
Opposite and hypotenuse. So it would be 4 over 5 for these angles. How far is the base of the ladder from the wall? So you're searching for that side right there.
That's Pythagorean theorem.
Yeah, Pythagorean theorem. And we've had this triple before on the same test. 4, 5, and what's the missing side? 3, that's right. Or you can do the Pythagorean. If we're looking for the distance of the ladder from the base of the wall there on the ground, then notice that this Pythagorean triple 3, 4, 5 is here, but none of those answers is 3 in there. So what you have to come up with is something that will fall into a multiple. So instead of 3, 4, 5, you could have 6, 8, and 10. That's another Pythagorean triple, which you just double all those numbers in the triangle. If you triple them, you get 9, 12, and 15. And if you multiply them by 4, you come up with 12, and then 16, and 20. So can you see what the answer is going to turn out to be?
12.
You think it's going to be 12? Well, there's one piece of information that has not been used yet. Can you figure out what it is? What piece of information in that problem has not been used yet? What number have we not used? We have we have angle in degrees, and we used the 4/5. So what else is in that problem that we haven't used? At the very beginning.
25.
25-foot ladder, yes.
Gee whiz.
If it's a 25-foot ladder, then we can keep going here. What has happened to this to get to 25?
Times it by 4. 5.
Times it by 5, yes. So here we'll make another triple. Instead of filling in all the ones that fall in between this one and this one. If I multiplied that by 5, what's this one going to be? 15. And of course the other one would be 20, but this is what we need. So the answer is D. There's many ways you can do this problem, but we'll start with this. The height of that trapezoid is going to be 4x. And if this is 12x all the way across, and this is 6x right there, what's the measurement of this and this?
3.
Yeah, we're 12 all the way across, 12x, we have 6x here, we have 6 left over, so we break them in 2, and we'll end up with 3x. Okay, so the area of the trapezoid. There's a shortcut way to do this, but we can just do it piece by piece for right now. This times this is 12x squared. If you divide it by 2, as the formula says to do for a triangle, you get that. But how many of these are there? There are 2 of them, so those cancel out. And we have 12x squared for the triangles. And then here we have 6. 6x times 4x is 24x squared. If you add those together, it's 36x squared. And the area of the trapezoid is 144. So x squared equals 144 divided by 36, which is how much?
4.
4, and therefore x has to be equal to what?
2.
2.